Welcome back. Today we're going to talk about the slope of a line, okay? And it's going to relate to the rate of change that we talked about yesterday. Okay, so we talked about the rate of change yesterday, and we talked about how sometimes it can be constant and sometimes it can be variable. All right, so let's talk about what happens when it's constant, what the graph of the function looks like. So when the rate of change of a relationship is constant, right? So this was the graph from yesterday where it was Nathan was biking, right? Over a certain amount of time, he biked a certain amount of miles. So a point like 460 would represent biking for 4 hours and traveling 60 miles, which is a pretty long time to bike and a long ways to bike, but maybe Nathan's a true biker. So, but when the rate of change, so we found the rate of change yesterday, and we found that between every 2 points it was the same, that the y variable went up 15 and the x variable went up 1, so we had a rate of change of 15 over 1, which was 15. And we found that to be the same between any of the 2 points that were set aside here. So the rate of change was constant for our biker Nathan here, that he went 15 miles every hour that he biked. Now it turns out that when any segment, when the rate of change of a relationship is constant, any segment of its graph has the same steepness because it's going up and over by the same amount. It's always going up 15 and over 1, going up 15 over 1, going up 15 over 1, so that the points on the line, the points on the relationship that make the relationship up actually form a straight line. Okay, because when points have the same steepness between them, it's actually going to be a line. All right, so the constant rate of change is actually called the slope of the line. All right, so slope is rate of change for a line. So we were introducing a new vocabulary word, slope. Slope is the rate of change of a line. So rates of change, we can get rates of change for things that are curves or things that are lines, but slope is a particular word referring to the rate of change of a line. And we know the rate of, so along any line, the rate of change is constant. Okay, so let's talk about the slope formula because it comes in many different, it looks very different sometimes. So the slope formula is equivalent to the rate of change formula. It just uses the coordinates of the points, okay? So we call the first point, we say that the coordinate of the first point is x, and this little one here is in this subscript, it's called, which means that it's positioned lower and to the right of the x that it's defining. All right, and this is a way to mark the difference between the two x's here, because if we're looking at two different points, then the two different x coordinates are going to be, you don't want to mistake them. All right, this is x sub 1 comma y sub 1. That's how you read this coordinate. And this sub 1 says that it is the x coordinate in the first point and the y coordinate in the second point. Now these subscripts are not like superscripts. It's not the same thing as an exponent. Okay, it's not asking you to raise x to a certain power. Like right here, this is not x sub 2. It does not mean the same thing as x squared. X sub 2 refers to a particular type of x. So it's a way of defining. Like it's like an adjective, for instance, like the pretty girl, where pretty becomes a way of describing what the girl is, right? This is the same as this subscript. It's x sub 1, so it's not only the x coordinate, but it's the x coordinate in the first point. Same with this x sub 2 here. So it's the x coordinate in the second point. And likewise with the y coordinate. Y sub 1 is the y coordinate of the first point, and y sub 2 is the y coordinate of the second point. All right. So to get the slope or the rate of change, what we're going to do is we're going to take two y coordinates, like this one and this one, and we're going to subtract them, right? That's the difference between the two y coordinates. And we're going to divide that by the difference between the two x coordinates. And actually, we're not going to go through with the division. Slope is written as a fraction. So you're always going to want to keep slope as a reduced fraction, even if it's improper. We do not write slope as a decimal unless we are using statistics, unless we're in the area of mathematics called statistics. If we're just in algebra, we are using slope as a fraction. All right, and we never write it as a mixed number. It's just a tradition that we have. It's actually easier because it's slope, if we continue to keep it as a ratio, it's easier for us to see what the change of y is versus the change of x, and it gives us a way to describe the line. Okay, So this is the formula that we do. We take the y coordinate. So for instance, we can take two coordinates here, and we'll say, okay, this slope is equal to 30 minus 15. And I don't need parentheses here. I'm not really sure why I put them, just force of habit, over 2 minus 1. So we're taking the y coordinate of this point, subtracting the y coordinate of the second point, of the first point rather. This is the y coordinate of the second point minus the y coordinate of the first point, and the x coordinate of the first point, second point rather, sorry, and subtract the x coordinate of the first point. That would be 15 over 1, which is 15. This is what we did yesterday. I just didn't introduce the formula to you. Now, oftentimes we see the letter M stand in for slope, and I'm not really sure where that tradition came in, but in algebra, definitely we use M in a specific context where we're looking at the equation of a line, and we're going to see that a little bit later. Okay, so M is what we refer to as slope. It's just a variable that stands in for slope. Okay. All right, there's another formula, and it uses this symbol that's called a delta. Now, in ancient Greece, delta was actually a letter in the Greek alphabet, and this is actually the capital letter. The lowercase letter looked like this little notation here, okay? So delta over, because a lot of mathematics was developed in ancient Greece, and a lot of philosophy. Ancient Greece was pretty amazing for science, philosophy, and mathematics. That a lot, delta over the years has been used by mathematicians and scientists to represent the idea of change, okay? Now, again, it's just a letter in the alphabet, just like M or X. So I said that a letter in our alphabet, M, refers to slope. Similarly, in ancient Greece, a lot of mathematicians and scientists use this delta. It's like a triangle with a bolded right side here. It used this a letter in their alphabet to represent the idea of change, okay? So the slope formula, another form of the slope formula is to represent it as the slope, M, is equal to the change of y over the change of x, because delta is standing in for the word change, okay? So sometimes we'll say slope is equal to delta y over delta x. I wrote it here as if someone was speaking it. Delta y over delta x is equal to the slope, all right? Where delta means it's the change in y coordinates. How do you get the change in something? Well, you subtract the coordinates, and that's what we saw with the formula at the beginning of the lesson. Okay? And thirdly, sometimes the slope formula is referred to as rise over run. All right, so rise being the change in the y coordinate between the 2 points, right? Because the y coordinate is the vertical coordinate. So in a point, the y coordinate of this point takes up the vertical distance, and the x is the horizontal. Remember, this a straight line up and down. That's the vertical. That's a vertical line, and left to right is horizontal. Okay, that's something that's really important to remember. You need to memorize these things. So rise over run is like a mnemonic. It's a memory aid in order to figure out the ratio, what should go in the numerator of the ratio and what should go in the denominator of the ratio. So you have rise over run. The rise between these 2 points, well, it's positive because the line is going up, so it's increasing by 2. The run is also positive because this one had a smaller x coordinate than this one. So here the slope would be referred to as 2 over 3. So m would be equal to 2 over 3 in this situation. All right, because the rise is 2 and the run is 3. And remember, we just leave it as a fraction. We don't try to turn this into a decimal, or in this case, it wouldn't be a mixed number, but we leave it as a reduced fraction. If I had 4 over 6, I would reduce it to 2/3, but that's as far as I would go. Okay, so 3 different ways of saying the same thing. This is the formula, and this is a way of referring to the slope formula by using the ancient Greek letter delta to refer to change. Okay, and this is a mnemonic that people use in order to remember which change goes in the numerator and which change goes in the denominator. Because sometimes students will flip them around and say x over y instead of y over x. So this is a memory tool to figure that out. Okay, so let's practice finding the slope of a graph. This is a straight line, so the rate of change is referred to as a slope. It shows the rate at which water is leaking from a tank. The slope of the line gives the leaking rate in gallons per minute. Find the slope of the line. So here's 0.2 and here's 0.1. Now, 0.2 here has a coordinate, has an x coordinate of 8 and a y coordinate of 6. And here it has a 0.1 has a coordinate, an x coordinate of 4 and a y coordinate of 3. All right. So one way I can do it is I can do it using the formula, which is the change of y here, which would be 6 minus 3 over, so m is equal to 6 minus 3 over 8 minus 4. So again, I'm not really sure why I use parentheses. It's just force of habit here. So it would be 3/4. So the slope is equal to 3/4. I can use the rise over run technique, especially when I have a graph. It's rise over run is particularly interesting when you have or particularly useful when you have a graph. Sometimes with tables you can't figure out rise over run as quickly, but when it's a geometric representation, I can always go, well, how much did it increase here? So I can make a little right triangle and say that here it went up by 3 and the run was 4. Okay, so that would again be 3/4. So the rise was 3 and the run was 4, creating a ratio of 3/4 here. Okay, so you may have asked yourself, and maybe you didn't, or maybe you did, why the point that I chose here was called 0.2 and the point that I chose here was called 0.1, because you are eventually going to have to choose which one is 0.1 and 0.2. You're going to eventually have to find the points and actually figure out ways of finding the slope yourself. So my question is, which point is 0.1? Well, the spoiler alert is that it doesn't really matter which point is 0.1. So what I did in this this slide right here is I switched around the 2 points. Okay, so once I switch around the 2 points, let's figure out what this the slope is from the formula first, and then see if it's the same as 3/4, right? This is the same problem that we had before, so the slope has to be the same. And let's make sure that it is. Okay, if this is 0.1 here, so this was 8, 6, and this was 4, 3. Okay, so the x sub 1, y sub 1 here would be 8, 6, and the x sub 2, the y sub 2 here would be 4, 3. Okay, so that's a 4 right there. So the formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is going to be equal to, okay, so y sub 2 is going to be the y coordinate here. Let me use a different color. So this is the 3 minus 6, so it's going to be 3 minus 6, okay? And here it's going to be x sub 2 is going to be the x coordinate of the second point, which would be 4 minus 8. So up top you get -3 over -4, which, remember, 2 negatives make the entire fraction positive. Okay, so this fraction is positive, so here you are going to be, it's going to be the same slope as we had before, which is 3/4. Now we can see the rise over run by looking at the going from 0.1 to 0.2, I would drop down by 3, so it would have a negative rise, and I would run over by -4. So again, the rise would be -3 over -4, so m would be -3 over -4, which would get you 3/4. So I did it using rise over run, and I also did it using the formula. I got the same thing. So it doesn't matter which point you use. Okay, it just matters, like if this were 0.2 and 0.1, it just matters how you put it into the formula. So never switch your y2s with your y1s. Okay, so always just be very careful. Sometimes with the coordinates, I actually should write this x2 over y2 above it so that it's easy to figure out which one's equal to which one. Okay. You can either, if you have a graph, you can use the rise over run situation, or you can use the formula. If you have a table, you're going to have to use the formula. And finally, we're going to talk about how to find a slope from a table. Okay, so from a table, we're just going to have to pick out 2 points. And if we're already told that it's a line, We know that the rate of change is constant, then it doesn't matter which 2 points I have to pick out. Okay, so let's pick out a couple of points here, maybe this one and this one, doesn't really matter. Let's decide which one's x1. So let's say that this is x1, that would make this y1. This is x2, and that would make this y2, right? Because these are coordinates, right? These really stand in the place of coordinates, because I have my x on my left and my right on my y on my right. So the slope formula is going to be y2 minus y1 over x2 minus x1. So that's going to be 18 minus 13 and a half over 4 minus 3. Okay, so this right here would be 4.5 over 1. So that's just going to be 4.5. Well, it's just going to be 4.5. But remember, we don't keep it as, we want to keep it as an improper reduced fraction. So here, 4 over 1 becomes the mixed number 4.5. So let's put this into 9 over 2. So the slope here is going to be 9 over 2. Okay? And so if you're finding slope from a line, you pick out 2 points and you put it into the formula. If you're finding it from slope from a table, you decide what 2 points you would like to use. Doesn't matter which 2, because the rate of change is constant in a line. And you put it through the formula, and you keep it as a fraction, either improper or proper, but always reduce the fraction. And that's the end of the lesson for today.